Hello friends, in this session we will be dealing with some small topics of calculus, very minor topics called as the mean value theorem, Rolle's theorem and maximum minimum of a function. So let's start with mean value theorem first. The statement of the mean value theorem goes in this way: let f be a continuous function in the closed interval a and b. Let f be differentiable in the open interval a and b. Then, so f is continuous in the closed interval a comma b, shown by the square brackets. F is differentiable in the open interval of a and b. Then there exists at least one C a point in a comma b such that f dash c is equal to f of d minus f of d upon b minus a. So what does mean value theorem give you? For an interval a and b, f is continuous and differentiable in the open interval a comma b, then there is at least one point c which would be having the slope of the function at that point to be equal to f of b minus f of a upon b minus a. The extension of the mean value theorem is taken in the Rolle's theorem. And we call as the corollary of the mean value theorem. What you have? Again the same thing, f continuous in the closed interval a comma b, differentiable in the open interval a comma b, and so let's have that f continuous and derivable. Then one more thing, condition is f of a is equal to f of b. If f of a is equal to f of b, then f dash c is equal to 0, which you can put in the mean value theorem and get your f dash of c. Now how this role f dash of c would be useful? If your first order derivative is equal to 0, that means you have some optimal point. It may be a maxima or minima of a function that would be obtained through the second order derivative test. But necessary condition for a point to be optimal is f dash of c to be equal to 0. So you can have some minor sums based on this. Simple examples: a function is given within an interval a comma b. You need to evaluate f dash of c or find the point at which f dash of c would be equal to f of b minus f of a upon b minus a. Since you have the function f dash of x, you know f dash of c, equate that and get the respective x. So the next smaller topic, maxima and minima of a function, somewhat related to f dash of c to be equal to 0. For any given function f, you can find the maxima and minima of that function. It can be a local maxima, local minima, or absolute maximum or absolute minimum. When we say local, what does that mean? Local means the function, say something like that, you have point A, B and C, which I have denoted. Points A and C are having some minimum value. So A and C can be called as the minima. B and D can be called as the maxima points. But not the absolute maximum. When we call it local, point D is local maxima, because if we take any point in the neighborhood of D, it will have the value less than f of D. Similarly, point C can be called as the local minima if in the neighborhood of C, you evaluate the function at any point in the neighborhood, it should be greater than f of C. Then it would be called as the local minima, and D would be called as the local maxima. To get the absolute maxima and absolute minima, what you have to do is you have to evaluate first all the optimal points through f dash of x to be equal to 0. Get all the optimal points, maxima and minima. Then evaluate the functional values at those points. Now those optimal points you can further classify as minima and maxima based on the second order derivative test. Which is, if the function is said to have a minimum point, it would give you f double dash of x at that point to be greater than 0. For maxima, f double dash of x to be less than 0. Now why does this condition arise? Say you have a function f of x evaluated at x1, evaluate the constant value at x2. So you have now f of x1 and f of x2. F of x1, f of x2. If f of x1 is less than f of x2, that means the function value is increasing, and it would be called as the increasing function. So now for this function, if you find out f dash of x, what it would be? It would be positive. Similarly for a decreasing function, because f dash of x would be what? F of x2 minus f of x1, limit of forward point minus the backward point, some limit h tends to 0, f of x1 plus h minus f of x1 upon h would be your f dash of x1. So if the function value is increasing, then f of x1 plus h would be greater. So f dash of x1 would be positive. Similarly for a decreasing function, your f dash of x1 would be negative. Now if you are at the local maxima, say at point B, which is called to be a local maximum, what would happen? The function value, as you move from the local maxima towards the right, what happens to the function value? It decreases. And when you have reached up to point B, the function value was increasing. Here the function value is decreasing. So what about your f dash? F dash would go from positive to negative for a point in between would be the local maximum. If you are moving from local minima, function value would, so at C, which is the local minima, the function value on the left hand side is decreasing, on right hand side it's increasing. So your f dash on the first order derivative will move from negative to positive, and in between at C it would be 0, which would be a stationary point or the optimal point. Coming to f double dash, what would be f double dash? Say at point B, for a local maxima, we say f double dash should be that's now you are at point B, you are moving further away from point B. What happens to f dash? F dash is negative. So now f double dash at x1 would be f dash x1 plus h minus f of x1 upon f dash, that would be h. Now as you move from right of B, function value is decreasing. So f dash of x1 plus h would be less than so you know the f dash of x1 plus h. Function value decreases, your f dash is negative. So when you evaluate the second order derivative, it would come out to be positive. Hence the condition at the stationary point or the critical point, you have find the maxima and minima for a given function f of x. First thing, evaluate f dash of x, equate it to 0, get all the optimal points. Then for each of the points, evaluate the second order derivative. If it's less than 0, it would be a maxima point. If it's greater than 0, it's a minimum point. And what if f double dash of x is equal to 0? It would be called as the point of inflection. So that's all with the maxima and minima of a function. This session, minor topics which we dealt with were mean value theorem, Rolle's theorem, and maxima and minima of a function. To get the absolute maxima and minima, you have to compare all the local maximas and the local minimas, and then the one which would be having the least value would be the absolute minimum, and the one which would be having the highest value for the function would be the absolute maximum for that function in that given interval. So that's all with the maxima and minima of the function, mean value theorem, and the Rolle's theorem. Try to solve some sums based on maxima and minima of the function, so that becomes more clear.